In this lesson, we're going to learn about reciprocity theorem. I'm going to explain this theorem using some examples. Okay, so let's look at that. So I'm going to draw a circuit here. Okay, so let's look at this circuit closely. So I have a 20 ohms resistor here. Then I have a 10 volts voltage source here. And also I have another resistor here. This will be a 5 ohms resistor. Okay, then I have another resistor here. So this resistor will be a 30 ohms resistor. So I have a current here which I'll name as okay, which I'll name as I. So this is I. And I'll name the current from the source as IS. Okay, so with this circuit here, okay, what you are going to do is that you are going to calculate for the value of what this I here, which is the current flowing through this branch, okay, which is the current flowing through the middle branch. So let's calculate for I. To calculate for I, you will first have to calculate for the total current in the circuit, okay, and then you will apply what current division rule to calculate for the what current I. So before you can calculate for the total current in the circuit, you have to calculate for the what effective resistance. Okay, so let's do that. So that will be this 5 ohms and then this 30 ohms resistors will be in parallel connection. So that will be 5 will be parallel to 30. Okay, then at the end they will be in series with the 20 ohms. So doing this, we'll have 5 times 30 divided by 5 plus 30. Okay, this plus what 20. So let's simplify this. So simplifying this, I'm going to add what I have here. Okay, so that will be, let's simplify that part first. That was 5 times 30 divided by 5 plus 130. So that gives me 30 on 7. So that will be 30 on 7 plus 20. So when I add 20 to the 30 on 7, that will give me 170 divided by 7 ohms. Okay, so let's change this to decimal. So that will be 24.29 ohms. So that was the effective resistance for this circuit or the total resistance for the circuit. So now you have to use it to find for the current IS, which is what the source current. So you have the source current to be equal to voltage divided by the resistance. So that will be equal to the 10 volts divided by 24.29 ohms. So let's see the value of the source current. So you have the source current to be equal to 0.41412 amperes. So that's the source current here. Okay. Now I want to find the current I, which is what flowing through the middle branch. How are you going to do this? So to calculate for current I, you are going to apply the current division rule. Okay, so you have I to be equal to the total current, which is what 0.412 amperes, multiplying this resistor here. Okay, so that will be times 30 divided by the sum for this resistor and then this resistor, which is what the 30 and then the 5 ohms. So that will be divided by 30 plus 5. So let's see what you get for current I. So I'm going to multiply these two values at once. So that is 0.412 times 30 on 35. That gives me a current value of 0.353. Okay, 353 amperes. So that's the current I flowing towards the middle branch. Okay, so let's write it down. 0.353 amperes. Okay, so look at what you are going to do here. What you are going to do here is that you see where this current I is indicated. Okay, you are going to take it from there and then bring the voltage source rather to where the current I is, and then we take current I to where the voltage source is. Okay, so let's see. So I'm going to redraw this circuit here, okay, by interchanging the position of the current and then that of what the voltage source. So I'm going to redraw this circuit here. Okay, so let's look at that. So now this is what I have. So I have 5 ohms here. Okay, I have the 20 ohms here, and then I have the voltage source here. Okay, so this will be the 10-volt source, and then you have one resistor here, which is the 30 ohms resistor. So this is the 30 ohms resistor. Okay, so let's continue. So due to the position of the positive terminal of the voltage source, I'm going to indicate the direction of the current I to be in this direction here. Okay, because you have the positive terminal here. So the current I has to be in the same direction as what the direction for the voltage source. So this is I. Okay, and then I have IS to be in this branch here. Okay, so now all you have to do is to calculate for the value of what this current I here. Okay, and see what will happen. So to do this, I will have to calculate for the total resistance in this circuit. So from here, you will see that this 20 ohms here and then this 30 ohms resistors are in a parallel connection, simply because I can pass through these two resistors without passing through any other circuit element, which means I can move from the 20 ohms resistor all the way through the 30 ohms resistor without passing through any other circuit element. So we see that these two resistors are in a parallel connection, or you can see that they are connected to same nodes, okay, which is this node here and then this node here. They share these two nodes, so they are in a parallel connection. So the effective resistance, I have what 20 parallel 30. Okay, and they'll all be in series with the 5 ohms, so that's what plus 5. So this will be equal to 20 times 30 divided by what 20 plus 30. All this plus what the 5. So let's simplify this. So 20 times 30 divided by 20 plus 30. That'll give me 12. Okay, so 12 plus 5. That'll give me 17 ohms. That's what the total resistance for the circuit. So now you have to calculate for the source current, which is what IS. So you have IS to be equal to what? The voltage divided by what? The resistance. Okay, so that will be equal to 10 volt divided by 17. So that give me IS to be equal to 0.588 amperes. Okay, so that's what the source current. Okay, so now we need the current flowing through at this 20 ohms resistor here. Okay, so how are you going to do that? To do this, we can use the current division rule here. Okay, so let's look at that. So we have I, which is the current flowing through this branch here, okay, to be equal to the total current, which is what the source current, that would be 0.588, okay, times this 30 ohms resistor here. Okay, so that was times 30 divided by the 30 plus the 20 ohms. That what 30 plus 20. So let's see the value of what I. So that'll be 0.588 multiplying 30 on 50. That gives me I to be equal to 0.3528, okay, which is approximately equal to 0.353 amperes. So what do you see here? So you see that in these two circuits that I have here, okay, first one, for the first circuit, considering where the current I was, okay, and then where the 10 volts voltage source was, we got what this current value here, 0.353, okay, and then after that we interchanged the positions, okay, we got the 10 volts source here, and then got what the current here, and then we still got what I to what 0.353. So you see that what even though we interchanged the position of the voltage source and then the current, but the current value didn't change, okay, we still got the same value for the current. So this is what reciprocity theorem says. It says that the voltage source and then the resultant or the resulting current may be interchanged, okay, without a change in the current value. So we can interchange the voltage source and then the resulting current. Okay, we can interchange their positions, but there will be no change in the value of what the current. That's what reciprocity theorem says. Okay, so let's take another example to help us understand this better. So I'm going to write down the next question so that we look at that also. So I'll go ahead and then draw the circuit. Okay, so the circuit here, I have a 12 ohms resistor here. Okay, then I have a 45 volt voltage source here, and I have a 6 ohms resistor here. Okay, and then I have a 2 ohms resistor here, and lastly I have a 4 ohms resistor here. Let me draw this. I have 4 ohms resistor here. Okay, so we have to calculate for the current in this branch here. Okay, so that's current I. Then I have the current from the source to be Is. So you have to calculate for the value of this current here. Okay, then after that we interchange the current and then the voltage source, their position. Then we calculate for the value of what I again and see if we get the same value. Okay, so let's do this. So to calculate for I, you first of all have to what, know the source current. And we can't know the source current without knowing the total resistance of this circuit. So let's calculate for the total resistance. So for the total resistance RT, these 2 ohms and these 4 ohms resistors will be in series. Okay, because what the current that flows through them, the current that flows through them is what this current I here. So that what 2 plus 4. Okay, and then after that they will be in a parallel connection with the 6 ohms resistor. Okay, which is what this is ohm that I have here. Okay, and then they'll all be in series with what the 12 ohms resistor. So you have RT to be equal to what 6 times 6. Okay, this 2 plus this 4, that gives me 6, and then there will be in parallel this 6 ohms. That was 6 times 6 divided by 6 plus 6 plus 12. Okay, so we have what RT to be equal to 6 times 6 divided by 12. That gives me 3. Okay, so I have what 3 plus 12. That gives me 15 ohms. That got the total resistance for this circuit. So now that we know the total resistance, we can find the source current. The source current is equal to the voltage, okay, divided by the total resistance, which is what 15. So let's see the value of this. So 45 divided by 15, that will give me is equal to 3 amperes. So now you know the source current, okay, so you now have to find the value for this current I here. So to find the value of what current I, you can apply what the current division rule. Okay, so you have I to be equal to the total current from the source, which is what 3 amperes times this 6 ohms here. Okay, so that will be 6 divided by what the sum of these two resistors, which was the 2 ohms and then the 4 ohms. That give me 6. So 6 plus the 6 ohms here again. That was plus 6. Right, so you have what I to be equal to what 3 times 1 over 2. Okay, and that gives us I to be equal to what 1.5 amperes. So with this circuit, okay, we got I to be equal to 1.5 amperes. So apply reciprocity theorem here. We are going to interchange the position of the current and then that of the voltage source, and then see if we get the same value for current I. So let's go ahead and then do that. Okay, so I will draw my circuit and then simply interchange or reciprocate the voltage and then the current. Okay, so I'm going to reciprocate them. That's the real thing. So that means what I'm going to interchange their positions. So I'll draw my circuit again. Then I have the 12 ohms here, and I have this 6 ohms here, and then I have 2 ohms here. Okay, then I have 4 ohms here. Then this time around, I'm going to bring the voltage source here. Okay, so that's the 45 volt. Okay, because at first the current was in this branch, but now I've taken it out and then brought the voltage source here. So in this case, the current will have to be in this branch here. So this is the current I. Okay, this is I. And then we now have what IS here. Okay, so now you have to find the value of what I. Okay, so let's calculate for the value of what I. To do this, you must first find what IS. And you know you can't find IS without knowing what the total resistance for the circuit. So let's calculate for the total resistance of the circuit. So that will be RT. These 12 ohms and these 6 ohms resistors will be in parallel connection. So that what 12 parallel 6. And then they'll be in series with these 2 ohms and then these 4 ohms. That what 2 plus what 4. So doing this, we have what 12 times 6 divided by 12 plus 6. Okay, all this plus 6. So let's simplify this. So 12 times 6 divided by 12 plus 6. That will give me 4. And plus this 6, that will give me what 10 ohms. So the total resistance for the circuit is what 10 ohms. Now you can find what the source current, which will be 45 divided by what 10, which is what the voltage divided by what resistance. So that will be 4.5. Okay, so we have what the source current is what 4.5 amperes. So now you know the current, the source current. Okay, you have to find what the value of what I. You can find the value of I by applying the current division rule. So to do this, we have I to be equal to what? Since I, okay, is in this branch here, okay, we are going to multiply the total current, which is what 4.5 times this resistor here. This is ohms resistor. So that what 4.5 times 6 divided by 6 plus what 12, which is what this 12 ohms here. So let's see the value of I. That will be 4 4.5 times 6, okay, divided by 18. So that gives me I to be equal to 3 on 2, which is much of 1.5 amperes. So instead with this circuit also, after interchanging the positions of the voltage source and then the current, we still got what I to be what 1.5 amperes. So what this means is that if you have an ideal voltage source and then an ammeter, okay, when you interchange these two devices, okay, when you interchange the voltage source and then the current, okay, the reading on the current shouldn't be what affected. Okay, so is that as at this for this circuit here, you have what the 45 volts here, and then you have the current in this branch here. Okay, and then you got what 1.5. Then here also we interchange their positions. Okay, so you have the 45 volts here, and then you have what the current source here, but you still got what I to what 1.5. So what that means is that even if you reciprocate the positions of what the voltage source and the current, we still get the same value for the current. So that's what reciprocity theorem says. And then also the direction of the current I here, okay, will depend on what the voltage source. Okay, so depending on the direction of the voltage source, that will be the direction of what the current I. So that's all for this lesson. Thank you very much for watching. Please don't forget to like and subscribe.